Hello, this is Tehmina Khan, TK, and I'll explain in this video the basic differentiation of exponential function and logarithmic function. Though I wanted to explain in the previous video in which I explained the differentiation of polynomial and trigonometry, but the size was increasing. It was of 26 minutes, and I try to keep it up till 20 minutes so that sometimes the students just want to listen part of it, so I think it's easy to upload also. So that's why I'm starting now the differentiation of exponential and logarithmic in this video. And again, on the top you can see the blog address of my blog, where I have put the link of all my previous videos so that it is easy to access. So let's see the exponential function differentiation. Okay, so because chapter 19 in the book is about differentiation of exponential function, so I have picked up question here from exercise 19.1. First of all, I'll talk about general form of the differentiation of exponential functions. Then I will pick up particular questions. So if it is e power x, this is an exponential function, and you have to differentiate it, the procedure is, or the process is, that it remains as it is multiplied by the differentiation of the power. So differentiation of x is 1, so that's why it is like this. Let's see here. I'm not showing you the solution, but let's see you can figure it out or not. So what it will become when you will differentiate it. Yes, first of all, the function as it is, so it will e power ax plus b and multiply by the differentiation of the power, and power is this. So what is the differentiation of this? A, and differentiation of this is 0. So it will become this, right? So I will just rewrite it, and this is my differentiation of exponential. So now let's take few example from exercise 19.1. This is my first example. Y is equals to e power minus 2x. So like I said, in differentiation it will remain as it is first of all, and multiply by the differentiation of the power, which is minus 2. So now you can rewrite it, and neatly it is like this. Okay, so now another example. If you see here, this is the question. So before I show you the solution, can you tell me what this will become? Let's do together, okay? So because there are two terms, so we will apply differentiation on each term individually. So e power 9x, what it will become? As it is, multiply by the number 9, because the differentiation of 9x is 9, right? Whereas if you see here, mostly students make mistake immediately, but overall this is just a representation of a constant number. Yes or no? 2, e3, there is no variable. We are differentiating with respect to x. So when there is no x term and it is just a constant number, and we know that the differentiation of a constant number is 0. So that's why this term will become 0. Right? So your question will be 9 over 3. This thing as it is, you simplify and you will get this. So this is your differentiation of exponential function. Let's take another example. Now if you see this example, it looks little different at a glance, but actually it is not. You know why? Because if you can recall indices, rule of indices, law of indices, the base is same and there is division sign in between. So what should I do? I should simply take this denominator on the top with the negative and simplify it. Yes or no? So it will become this. After that I will differentiate it. Right? So in differentiation of exponential, what did we learn? As it is, multiply by the differentiation of the power, which is 1 in this case. So this will be my differentiation of the exponential function, which was written in the form of fraction. Right? Okay, let's take an example of exponential function type, right? Which we have done in polynomial also and trigonometric also. So when you will differentiate it, 5 will come here as a multiplier. This will remain as it is. 5 minus 1, 4, multiply by the differentiation of this function. So this is 1. I mean, when I will differentiate, it will become 1. And what about this? As it is, multiply by differentiation of this, which is 1. So I can write it like this. Yes, makes sense? So I'm just rewriting it. So this is the gradient function for this function. Let's see the last example for the exponential function, then we will start logarithmic function. So this means power half. Radical sign means power half. Okay? And when these two powers will multiply, it will become this. The question will become this. Now do you remember how do we apply differentiation? The function remain as it is, multiply by the differentiation of the power. See, this is what I have done here. Right? So differentiation of exponential function is pretty easy, and you just have to remember the ways how we will differentiate the exponential function, trigonometric function, polynomial. So let's start the last function, which is logarithmic function. Okay, so logarithmic function is in exercise 19.2, and because I have picked up only those questions which have basic differentiation available, the rest we will do later. Okay, so the function is y is equals to ln x. Now the technique is for gradient function, after ln whatever is written here, for example it is x, right? So it will go in the denominator 1 over that thing without ln, and multiply by differentiation of this, which is 1 in this case. I'll come back to this in a while. Let's see another thing. Suppose this is my function. So according to this rule, what should happen when I'm differentiating this? This should go in the denominator with 1 over this, and then I should multiply by the differentiation of this. And what is the differentiation of this? You remember? N will come here as a multiplier, and then n power 1 will be subtracted from n. So let's see. Yes, exactly the same we have done here, right? So now we will take few example, but before example, let's see here what I was writing here. It is just to tell you that if this is the question, you can be asked like this or you can be asked like this. Instead of y, the function itself can be written here in the bracket, so don't get confused, please. Okay, so let's see the example here now. Now this is my question. So how will I differentiate it? What is the method I told you? This thing after ln whatever is written will go in the denominator. So 1 over 5x plus 1, okay? And then multiply by the differentiation of this, which is 5 plus 0. So this is how you will differentiate it. Okay? So let's take 2 more examples and then we will be done with this. Okay, let's see this question. Y is equals to ln 4x minus 3 power 2. So again the same technique. When I will differentiate, this part will go in the denominator, so 1 over this here, and multiply by the differentiation of this. Now this is just like polynomial. You remember? 2 will come here, function as it is, 2 minus 1 is 1, and differentiation of this, which is 4 minus 0. And then you will simply simplify it. Is it okay? So this is your gradient function of the original function. Now the last question. Now this is the question given to you. Y is equals to ln x plus 1 x minus 3. They are multiplying. If I want to do it exactly the way I have explained to you, there is no harm, but it will become little lengthy. So we will apply the concept of ln we learned earlier in chapter 1, which is this: if ln is multiplying by two functions, we can write it separately like this with plus sign in between. So exactly the same thing I am doing here, x plus 1 plus ln x minus 3. So now these are my two terms, and what we have done in the above examples, we will do the same thing here. Now I am differentiating it. I did not differentiate here, I just simplified here the function. So now 1 over this thing as it is, multiply by the differentiation of this. So 1 plus 0, I have written 1. And in this case 1 over this, multiply by the differentiation of this, 1 minus 0, so I have written 1. After that I will simply apply algebraic fraction concept, taking LCM and simplifying it. I think you know this, how to do this, and then take common out. So you have your function here, gradient function. So with this I would say thank you very much for watching the video, and we are done with the basic exponential and trigonometric function. And if you like the video, you have learned something from it, please press the button like. You can give comments also if you want to bring any improvement in the videos, or if you want to appreciate the effort. So please do write comments and do subscribe. Thank you very much. Bye bye. Have a nice day.